Hi, and welcome to week 4, lecture 4A and 4B. Today we'll be talking about sensors and satellites. And so for today's agenda, we'll begin by discussing sensors and sensor types, passive and active sensors, and some sensor key takeaways. And then we will discuss for lecture 4B the major Earth observation satellites and 4 major satellites. So let's dive in. Remote sensing fundamentals. We briefly discussed this during week 1. And last week we learned that different materials reflect different wavelengths of electromagnetic energy. Today we're taking one step back and asking, but where does that energy come from? So passive sensors like Landsat and Sentinel-2 simply record sunlight reflected from Earth's surface, like in the right diagram. Whereas active sensors such as Sentinel-1, SAR, we'll talk about later in this course, but and like LiDAR, they generate their own energy, allowing them to collect data even at night, and in the case of radar, through cloud cover, and then measure that reflection. So this distinction is one of the most important concepts in remote sensing because it determines when and where different sensors can be used. Passive sensors measure reflected sunlight, whereas active sensors illuminate the Earth's surface with their own energy and then measure the return signal. I think I said reflection earlier. I meant return signal. Okay, so those are the two distinct sensor types. So with passive sensors, we just talked about the definition, meaning they measures naturally occurring electromagnetic energy that is reflected or emitted from Earth's surface. And our textbook for this course explains that passive sensors measure naturally available electromagnetic radiation, and most passive systems detect reflected solar radiation in the visible near infrared, so NIR, and shortwave infrared, SWIR regions. Thermally emitted radiation in the thermal infrared portion of the spectrum. And so unlike reflected sunlight, thermal emission can be measured both day and night, although temperature differences still influence image quality. And so the energy source for passive sensors is the sun. And some of these examples that use passive sensors types are Landsat 9, Sentinel-2, and MODIS, which we'll discuss later in this lecture. And then the characteristics is that it requires sunlight for reflected imagery and it cannot image through clouds. And then it's excellent for vegetation, land cover, and agriculture. Limitations of passive sensors include optical imagery depending on sunlight for reflected energy. But it's important to note that the visible and near infrared passive sensors do depend on sunlight, but the thermal infrared passive sensors detect energy naturally emitted by objects and therefore can operate both day and night. So it's a misconception that just because it's a passive sensor, people think that it needs daylight, but that's not true. Passive sensors can operate during the day and night. And so clouds, smoke, and atmospheric conditions can obscure the Earth's surface. So that's a limitation of passive sensors, and daytime acquisition is generally required for visible and near infrared imagery. And so let's talk about active sensors, systems that generate their own electromagnetic energy, direct it toward the Earth's surface, and measure the return signal backscatter. Because the sensor provides the illumination, active systems are largely independent of solar illumination. And some examples of active sensors include synthetic aperture radars, or otherwise known as SAR sensors, which we will discuss later in class, and LiDAR. SAR uses microwave radar pulses to measure the Earth's surface and is commonly used for applications such as flood mapping, sea ice monitoring, and detecting ground deformation after earthquakes or volcanic activity. And then LiDAR uses laser pulses to produce highly detailed measurements of surface elevation and vegetation structure. So because active sensors provide their own illumination, they can operate both day and night. Many active sensors, particularly radar systems, can also collect imagery through clouds, smoke, and light precipitation, making them valuable when weather conditions limit the use of optical satellites. One important point to remember is that active sensors do not measure color like optical satellites. Instead, they measure how the transmitted energy interacts with the Earth's surface. So because different materials reflect radar or laser energy differently, active sensors can reveal information that may not be visible in traditional optical imagery. So here's some key takeaways. Passive sensors such as Landsat and Sentinel-2 are the workhorses for mapping vegetation, land cover, agriculture, and water quality, which we looked at in the previous week's labs, and because they measure reflected or emitted electromagnetic energy. And then active sensors such as Sentinel-1, SAR, and LiDAR are used when conditions like darkness, cloud cover, or the need for precise elevation measurements make passive sense systems less effective. So this distinction helps determine which sensor is most appropriate for a particular remote sensing application. Following this lecture 4A, please take a look at the supplemental videos that go over some passive and active sensors in remote sensing. And following that, you will proceed to lecture 4B. Okay, thanks.